So here's another short chemistry review video that will review two particular skills, concepts, idea sets that are important for your chemistry exam. The first is looking at ionic compounds and how we form particular ionic salts from specific elemental ions. And the second is how we build molecules and draw electron dot structures from our stick structure. So let's do those and give you a chance to practice those on your own. So if we want to form an ionic compound, the first thing we have to know is which ions are formed by a specific element. So to do that, we need to look at the element in the periodic table, assess its position, and decide how many electrons it needs to gain or lose so that it can achieve a filled outer shell. Here's a nice periodic table that actually makes that point, and you can see everything that is in this row that we call group 7A that's one space away from filling an outer shell, like fluorine, chlorine, bromine, they all gain one electron. Fluorine gains one, chlorine gains one, bromine gains one, and because of that, if I want to know what ionic charge they'll acquire, they'll become a -1 ion because they gain one. Same idea for these that are in the group before, oxygen, sulfur, and selenium, they're going to actually need to gain 2. So if I think about oxygen, to get a filled outer shell, it will actually gain 2 electrons and become -2. And of course, nitrogen and phosphorus, if they ionize, -3. So those are our negative ions, or anions, and they gain electrons to fill their shell. If I go over to the left side of the periodic table, and I come over here in blue, I can see that these are elements that are going to need to lose 1 or 2 electrons to go backwards. And in going backwards, if I look, for example, at sodium, sodium just went 1 past a filled outer shell. So to achieve a filled outer shell, it loses 1 and comes back to being like neon. We say it has lost 1 electron, and in doing so, it becomes Na+1, or just Na+. And so Na+, the sodium ion, is isoelectronic with neon. That means it has the same electron configuration as neon. It does not mean that it turns into neon, just that it has the same electron number and electron configuration as neon, the noble gas. So here are some ions. Over here on the left, I have some positive cations. On the right, I have some negative anions. And what we want to do is think about the combining ratios that we would use to put them together to make an ionic compound. Now the goal for our ionic compound is that when the two things come together, that my combination of the X cation and Y anion will be neutral overall. So if they're neutral overall, I need to combine them in a ratio so that the positive charge in total offsets the negative charge in total. So let's erase this and let's actually think of a pair of these that we could look at as our first example. I think my eraser is a little thin and I could make it a little thicker and it would do a better job. So if I go back to my ions and let's pick out the calcium, Ca2+, and imagine combining it with an oxygen, which is O2-. Well, these are actually going to combine in a 1-to-1 ratio. If I get 1 of each, then the positive 2 and the negative 2 offset, and my resulting compound is just CaO. CaO is really Ca1O1, but we just don't bother as chemists saying the 1. We just say CaO, and CaO could be named calcium oxide because the oxygen, as the anion, changes its ending to IDE, calcium oxide. So there's our first one. If I wanted to think about combining a different pair, in this case let's imagine the sodium, but now with a nitride, Na+ and N3-, we need a different ratio. We will need 3 of the positive 1 sodiums to every 1 of the -3 nitrides. So my new formula is going to be Na3N, and I could name that sodium nitride. So that's my combining rules, that I combine elements so that overall their charge is neutral. And I need the right ratio of pluses to minuses to do that, and then name the compound. And remember, if I have a positive 3 charge like aluminum 3+, and a negative 2 charge like a sulfide S2-, now I'm going to have a combining ratio where each needs a multiple so that they can offset each other. So in this case, if I took 2 aluminum 3 pluses, that would bring a total amount of positive charge of 6 plus. And if I combine that with 3 S2 minuses, that's bringing a complete 6 minus, a total negative charge of 6 minus. And when I combine it that way, I get Al2S3. Al2S3, which is aluminum sulfide. Aluminum sulfide is the name. The positive ion retains its elemental name, and the sulfur changes as an anion to sulfide, Al2S3. Now, in a way, don't forget, Al2S3 is the way that we write something that really is Al2 of the 3 pluses and S3 of the 2 minuses, with the whole thing having an overall charge of 0. So if I were able to see that, I could actually imagine, I'm going to pull that over a little bit, that once I combine these, the whole goal is that the net charge of the entire thing becomes 0. So erase that line, we're all good. So here you can see my example of the stick structure of, again, the chemical formula of this C2H3Cl. And my first job in converting to a dot structure is to take every one of the bonds and turn it into 2 dots. So that's going to give me this, H dot dot C dot dot H. And then for the double bond, since each bond represents a pair of electrons, I'll have 4 electrons, and then a carbon, dot, dot, H, dot, dot, Cl. That's the first step, and then I need to check to see if all of my elements have octets. Or in other words, what I'm really checking for is to see if I have any unshared pairs, any electrons that are non-bonding that I need to put in here. Here you can see I've circled the octet for the carbon and the octet for the other carbon, but when I look at the chlorine here, the chlorine doesn't have an octet. The only thing it has right now are the 2 electrons that's sharing with carbon. So to fix that, I need to add the 3 unshared pairs, or the 6 non-bonding electrons that chlorine has. And now there's my complete correct electron dot structure for a molecule of C2H3Cl. So those are things you can practice. You have lots of structures you can try that with, and that should help you out in thinking about how to build these molecules.